Hello and welcome back to episode 7 of Polynomials. This is the second part of a two-part series on understanding the cubic formula. Today I will also be explaining the cubic discriminant, and for this video I will be looking at cubics of the form f of x is equal to x cubed plus p of x plus q. This is because I've already shown you how to turn any cubic into this form. If you haven't seen that before, look at my previous video, which is part 1 of Understanding the Cubic, episode pi. So, question I'm sure you're wondering at this point is, what are p and q? What on earth are they? So, q is the y-intercept, because if x is 0, which it is, at the inflection point, then all we're left with is q. So q is the y-intercept. Then, what is p? So p is just the gradient at the inflection point. To show this, f dash of x is equal to 3x squared plus p, which will be equal to 0 at the inflection point. No, sorry, it won't be equal to 0 at the inflection point. I'm talking absolute rubbish. X is equal to 0 at the inflection point, so all we're left with is p. So p is m, y equals mx plus c, m is just gradient. M at, I'm going to denote it by a little green dot at the inflection point. Then, looking at this graph, something I should say is that all cubics have a half-turn symmetry about the inflection point. In other words, this means if you were to rotate this graph 180 degrees about the inflection point, it would look the same as if you rotated it 360 degrees or just left it where it was. So for different values of p, how many solutions do we have? This is just breaking in the idea of a discriminant. So if p is less than 0, we have 1, 2, or 3 solutions. If real solutions, I should say. If p is equal to 0, we can have 1 real solution and 2 complex solutions, or 1 repeated real solution and 1 complex solution. If p is greater than 0, we can only have 1 real solution, because that looks like exactly what we've got here in our example. Looking down here, we have q, which is the value of q is the value of the y-intercept, which is just this green value here. And I'm going to refer to this, the difference in y values of the maximum to the minimum, as DIH, difference in height. If the difference in height divided by 2, so basically the difference from the height of the inflection point to this point here, so this distance here, if DIH over 2 is less than q, then there will be 1 real solution, because it won't cross the x-axis again or touch it at all. If DIH over 2 is equal to q, then there will be 2 real solutions. If DIH, difference in height, over 2 is greater than q, there will be 3 real solutions. Now for the algebra. So we know that f dash of x is equal to 3x squared plus p. And we know that when the f dash of x is equal to 0, that's where the x value of our maximum and our minimum. So we're going to put that equal to 0 and we're going to solve. So we have 3 x squared is equal to minus p. X squared is equal to minus p over 3. And x is therefore equal to plus or minus, that is very important, minus p over 3. So, the next phase is plugging this back into our original cubic equation of x cubed plus p times x plus q, and then finding the y values, and then finding the difference in height of these y values. So, the difference in height, I'm going to put a big minus here, and I'm going to write one y value here, and one y value here. So, the taller one, so the higher one up here, will be when the x value is negative. So we take the negative square root, this one. So we have minus the square root of negative p over 3 cubed. I put the minus outside the cube because cubing doesn't change whether it's minus or not. Minus p times the square root of minus p over 3. It's changed from a plus to a minus because we're using the negative square root value, plus q. I'm just going to put this up here in a corner. And then the other one will be simply minus p over 3 cubed plus p times the square root of minus p over 3 plus q. Now, these q's will cancel. And so what we'll be left with is, I'm just going to change colour again, if it lets me. What we'll be left with is DIY, great joke. DIY, difference in y value is equal to minus 2 times the square root of minus p over 3 cubed minus 2p times the square root of minus p over 3, and no q's because I told you they cancelled. Now, because we want to find half the difference in height, I'm going to halve this and I'm going to put it equal to q, just for easiness, just for ease. So, we have q equals y over 2, which is equal to minus the cube of minus p over 3 minus p times the square root of minus p over 3. And now we're just going to multiply out the brackets. So not the brackets, I'm going to actually cube it. So the minuses will cancel because minus p over 3 times minus 1 is just p over 3. So I'll have p over 3 times the square root of minus p over 3. That's the first term. Minus p times the square root of minus p over 3. And q is equal to that. Then I'm going to rationalise the denominator of the surd. And that will give me p times the square root of minus 3p over 9 minus p times the square root of minus 3p over 3. And what I'm going to do is I'm going to change that to a 9 and multiply this by 3. And that will then allow me, not p, what am I talking about? Q. That will allow me to say that q is equal to minus 2p times the square root of minus 3p all over 9. Multiply both sides by 9, I get 9q is equal to minus 2p times the square root of minus 3p. Now I've got one term on either sides and I want to get rid of a square root. So what do? I square both sides. And that will give me 81q squared is equal to 4p squared times by minus 3p, which is just minus 12p squared. Add 12p squared to both sides, and that will give me 81q squared plus 12p cubed, not squared. What am I talking about? Cubed, because we have this p, and this p was squared, so we have 2 and 1 multiplied together, and they add to make 3 because of laws of indices. And this expression will be equal to 0. Divide both sides by 3, and that will give me 27q squared plus 4p cubed is equal to 0. Divide both sides by 4, and then at the same time divide by both sides by 27. That will give me q squared over 4 plus p cubed over 27 equals 0. And I can just put these into brackets, which will be q over 2 squared plus p over 3 cubed equals 0. And that is your discriminant for the cubic, which I showed in a previous video. I'm going to put a little square because I'm very pleased with that proof, and I will see you all next time.